Titan, the largest moon of Saturn, remains one of the most fascinating and mysterious destinations in our solar system. It's the only celestial body, apart from Earth, known to have stable liquids on its surface. But here's the strange part. Those liquids aren't water, they're methane and ethane. On Earth, these hydrocarbons would quickly evaporate, but on Titan, they form rivers, streams, lakes, and even seas. In a world where temperatures plunge to a staggering minus 290 degrees Fahrenheit, these elements carve out an icy landscape like no other. Scientists believe Titan may experience weather patterns that resemble Earth's, complete with wind and rainfall. But instead of water, Titan's skies rain down liquid methane. Its thick, hazy, nitrogen-rich atmosphere paints a yellow-orange veil over the surface, making it feel like a world entirely detached from our own. Researchers have been left puzzled by the strange data captured by the Cassini spacecraft. Bizarre organic cloud formations, seasonal shifts in methane lakes, and mysterious chemical reactions unfolding in the atmosphere. What exactly is happening on Titan? Could this alien moon be hiding ingredients that point toward a form of life far beyond anything we've ever imagined? Join us as we uncover the secrets buried within Titan's frozen depths and confront the bigger question: are we ready to redefine life itself and push past the boundaries of what humanity thought possible? Titan has revealed itself to be a world that operates on an entirely different logic, a place that continues to astonish us as we begin to descend into its layered atmosphere, where light, wind, and time defy every pattern we know on Earth. Beneath its icy and seemingly still exterior, Titan is a planet of dynamic weather. According to data from the Cassini mission, Titan's atmosphere is composed of approximately 95% nitrogen and about 5% methane. Unlike Earth, where methane exists only in trace amounts, Titan boasts a methane-rich atmosphere that behaves like a vast chemical laboratory. One of Titan's most unusual traits is its surface air pressure, which is about 1.5 times greater than Earth's. Sunlight, heavily absorbed and scattered by layers of hydrocarbon aerosols, fails to fully illuminate the surface. Here, there's no true day or night, only a suspended twilight, where everything seems blanketed in a soft, dusty glow. Yet the moon is tidally locked to Saturn, meaning one hemisphere always faces the gas giant. This creates what scientists call terminator zones, regions where twilight never ends. In these transition areas, the climate is in a state of constant flux, producing extreme and persistent weather systems. Titan's rain system is no less peculiar. From high-altitude methane clouds, frigid droplets, larger and heavier than raindrops on Earth, drift slowly to the surface. But unlike Earth's frequent tropical downpours, Titan's rains are sparse, occurring only during seasonal cycles. A pattern confirmed by climate models and Cassini's observations. When it does rain, temporary streams flow across the land, carving visible erosion patterns captured by radar. Even stranger are the prolonged eclipses on Titan. Not caused by a moon, as on Earth, but by Saturn itself. This immense gas giant around which Titan orbits periodically blocks sunlight. This leads to sharp changes in local temperature and atmospheric structure, creating some of the most unique weather phenomena in the entire solar system. In certain regions of Titan, twilight seems eternal. These perpetual sunset zones may offer the potential for stable biospheres. If life could adapt to such unusual conditions, taken together, Titan is not merely a frozen moon. It is a living climate system governed by familiar physical laws, but expressed in unfamiliar ways. And perhaps, in this place where light never truly shines, life, if it exists, may take forms so alien, so unlike anything we know, that our imagination can hardly contain them. If Titan's atmosphere is a mysterious veil that conceals light and time, then just beneath that haze lies a dynamic geological canvas, where rivers, lakes, and seas are not made of water, but of icy methane and ethane. This isn't science fiction. It's a confirmed reality, revealed through spectrometers, radar, and imaging technology from the Cassini spacecraft, which for the first time peeled back Titan's atmospheric curtain to show humanity the only world beyond Earth with stable surface liquids. Even more astonishing, Titan hosts a fully functional liquid cycle, akin to Earth's water cycle, but powered by methane and ethane. In the extreme cold of -290°F, methane exists as a liquid and plays the role of water. It evaporates from lakes, forms clouds in the atmosphere, condenses, and falls back to the surface as rain. These liquid methane flows then travel across Titan's frozen terrain, draining into lakes and seas to complete the cycle. This isn't just a theoretical model. Cassini observed vast lakes and seas, concentrated mainly near Titan's poles, regions where temperatures are relatively stable. Brackenmare, one of Titan's largest seas, spans nearly the size of Earth's Caspian Sea and is filled with liquid methane and ethane. Seasonal changes in lake size and depth, tracked over years of radar observations, confirm that Titan's hydrocarbon cycle is real, active, and continuously operating. But this cycle goes beyond weather. It leaves a lasting imprint on Titan's surface. Topographical data reveal ancient riverbeds, sprawling erosion channels, and even deltas, where methane streams once branched out before pouring into lakes. These features suggest that flowing liquids have shaped, and may still be shaping, the Moon's landscape. A world where hydrocarbons function like water, carrying energy, transporting material, and sculpting terrain, challenges every classical definition of life and planetary science. The key difference lies in the chemistry. Water is Earth biology's universal solvent. Methane, on the other hand, is non-polar, yet that hasn't stopped scientists from asking bold questions. Could an entirely new biology evolve in a liquid methane environment? Could this methane-ethane cycle do more than just move energy? Could it provide the right conditions for non-traditional life? In its icy silence, Titan runs a chemical ecosystem all its own. Without warmth, without water, and without radiant light. If life has ever emerged elsewhere in our solar system, then perhaps it is here, where hydrocarbon rain falls gently, and geology and atmosphere become one. That we may discover a completely different version of life, quiet, hidden, yet no less magnificent. If the methane cycle is a quiet engine churning within Titan's thick atmosphere, then its surface is the canvas where that motion leaves its mark. A strange map drawn by wind, ice, and time. Contrary to the desolate stillness we might imagine, Titan's surface is alive, constantly shaped by geological forces, climate interactions, and external impacts. All unfolding in conditions of extreme cold and alien chemistry. One of the most striking features recorded by Cassini is a vast system of massive organic dunes stretching across Titan's equatorial region. These dunes can reach heights of up to 100 meters and extend for hundreds of kilometers, forming parallel ridges reminiscent of deserts on Earth, but with a fundamental difference in composition. Instead of typical silicate sand, Titan sand is made of solid hydrocarbon compounds like tholin, a material formed through photochemical reactions in its atmosphere. Under Titan's frigid conditions, these grains become flexible and light, yet they manage to accumulate through a process known as sintering, where particles gradually fuse under subtle pressure and temperature fluctuations over time. Though Titan's winds move slowly through its dense atmosphere, they are still powerful enough to shift these particles, driving continuous changes in the landscape. Cassini detected subtle movements in dune formations following seasonal shifts, a clue that the surface is far from frozen in time. And from these same winds come phenomena never seen elsewhere: hydrocarbon dust devils, black and amber tone dust storms capable of transporting fine organic material across hundreds of kilometers, spreading layers of prebiotic compounds across distant regions of Titan's surface. But it's not just wind and sand that tell the story. Titan also bears the scars of impact. Elongated craters near the equator suggest oblique impacts. Possibly from satellites orbiting Saturn and striking Titan at shallow angles. Meanwhile, polar regions show a more random spread of impact sites. Hinting at long-range visitors like comets or asteroids from the distant Kuiper belt. Many of these craters have slowly faded, filled by settling organic haze or washed by methane rains. Evidence that Titan's surface is not static. But instead reshaped by the passage of time and weather alike. Together, these elements point to a truth that can no longer be ignored. Titan is not a dead world. It is alive, just not in a way Earth would recognize. On Titan, every grain of dust, every whisper of wind, every drop of methane rain plays a role in a silent symphony of chemistry and physics, unfolding on one of the most mysterious worlds in our solar system. And if something lies hidden beneath those organic dunes, then perhaps Titan still has much more of its story left to tell. After passing through alien dunes, swirling organic dust storms, and scars from ancient impacts, we now descend deeper into Titan's very atmosphere. Here, Titan conducts chemical reactions unlike any other place. And most remarkably, it does so without water. Despite being over 1.4 billion kilometers from the Sun, ultraviolet radiation still reaches Titan's upper atmosphere. triggering a cascade of photochemical reactions between methane and nitrogen. These interactions give rise to a host of simple organic molecules. Acetylene, ethylene, hydrogen cyanide, all foundational compounds with the potential to kickstart early biological chemistry. As they continue to interact, they form increasingly complex particles, fine organic aerosols known as toluens, which gently fall to the surface like a prebiotic dust rain. These toluens, rich in molecular structure, are the main component of Titan's reddish-brown surface layer. They shape its dunes, haze, and airborne dust. But what makes Titan truly extraordinary isn't just the presence of organic compounds. It's the scale and process by which they're formed. Earth can also produce similar molecules. But only within thin layers of atmosphere or controlled lab environments. Titan, by contrast, does it planet-wide every day. This leads us to an unavoidable question. Could these simple yet potent molecules serve as the foundation for life? The answer remains elusive, yet one thing is clear. Titan offers us a glimpse into a wholly different chemical recipe for life, where biology might emerge not in the presence of water, but instead amidst liquid methane and a slow, constant snowfall of toluens. Paradoxically, it's Titan's lack of surface water that makes it such a compelling primordial laboratory. Scientists believe that some of Titan's more complex molecules have existed for millions of years, slowly accumulating and evolving, quietly setting the stage for more sophisticated reactions. Under the right conditions, those reactions may lead to life or to some form of self-organizing chemistry that mimics life. Titan isn't just another distant moon. It may be a gateway to a bold new question. If chemistry can breathe through methane, if organic matter can accumulate and evolve in a soft amber twilight, then perhaps the definition of life no longer belongs solely to Earth. Beneath Titan's thick atmosphere and the endless chemical reactions that unfold in its dim amber light, lies an even greater mystery, an entire world hidden below its frozen surface. Where water and ammonia silently persist in liquid form. If the upper atmosphere is a machine that transforms organic compounds, then this underground ocean may be where those compounds evolve. Under stable, energy-rich conditions, bringing Titan closer to the possibility of supporting life. Radar echoes gravity data and magnetic field measurements from the Cassini spacecraft provide compelling evidence that Titan harbors a liquid ocean. Beneath an icy shell 50 to 100 kilometers thick. This ocean is not made of pure water, but of a water-ammonia mixture. A kind of supercooled, salty liquid that remains unfrozen under high pressure. Even at the extreme temperatures of minus 180 degrees Celsius, ammonia lowers the freezing point of water and prevents the ocean from solidifying. An essential factor for sustaining any long-term geochemical activity. Separating the ocean from the surface is a special layer known as clathrate hydrate. Crystalline cages of ice that trap methane molecules. This clathrate shell, estimated to be 5 to 10 kilometers thick, acts as a natural thermal barrier while allowing materials such as methane, ethane, and small organic molecules to move between the ocean and the surface. This exchange likely occurs through slow convection or surface fractures. In some scientific models, this clathrate layer may even build up internal pressure, releasing gas or fluid through gentle eruptions. Similar to hydrothermal vents on Earth's ocean floor. It is at these interaction zones that science begins to propose a bold hypothesis. If this subsurface ocean has been collecting organic material for millions of years, and if geothermal energy is sufficient to drive ongoing chemical reactions, then this may be a place where life has already begun, or is actively unfolding in an extraordinarily different form. Just as Earth's deep-sea hydrothermal vents harbor life without sunlight or oxygen, Titan might be repeating that story. But in a far stranger chemical language. This striking parallel makes Titan one of the most compelling targets in the search for extraterrestrial life. Nowhere else in the solar system offers such a rare combination. An organic-rich surface, a stable water-based ocean beneath, and a means of chemical exchange between the two realms. This is not just an opportunity, it is a direct suggestion. That Titan could be the cradle of a form of life we've never seen before. And deep within those tens of kilometers of ice, there may lie a truth capable of reshaping our understanding of life itself. Not as something unique to Earth, but as an inevitable outcome of a universe that is diverse, ancient, and full of cosmic possibilities. If Titan's subsurface ocean harbors the potential to support life, the next great question is, what would that life actually look like? This is no longer just the realm of science fiction, it's an active field of research. With a growing number of scientists exploring the bold idea of non-water-based life. Grounded in liquid methane. On Earth, all known life revolves around water. It's a powerful solvent, highly polar, and stable across the biological temperature range. Cell membranes, the structural foundation of life, are formed from phospholipids suspended in aqueous environments. But Titan offers a radically different stage. Its surface is far too cold for liquid water, and instead, methane, a nonpolar solvent, dominates in liquid form. The critical question arises: could an entirely different biology operate using methane as its solvent? In 2015, a research team at Cornell University proposed a daring theoretical model. The azotosome, a hypothetical cell membrane that does not require water. Unlike Earth's phospholipids, azotosomes would be made from acrylonitrile. An organic compound that Cassini detected in Titan's atmosphere. In computer simulations and cryogenic experiments, these membranes demonstrated the ability to self-assemble, flex, and remain stable. Key traits needed to protect genetic material or catalyze chemical reactions, mirroring the role of biological membranes. What's remarkable is this: if something akin to a living membrane can spontaneously form in liquid methane, then Titan may not just be suitable for adaptation, it may already contain the chemical foundation for life vastly different from anything Earth has ever known. And to support this theory, we only need to look back at Earth itself. Life has been found in seemingly impossible places. From deep-sea hydrothermal vents to acidic lakes, and even within the frozen cores of Antarctic ice. Extremophile microbes like thermophiles, acidophiles, and heliphiles prove that life isn't just resilient, it redefines what habitable truly means. On Titan, its frigid temperatures, high pressures, and exotic chemistry don't eliminate the possibility of life. They simply reshape it. Theoretical life forms here might be methanogens, organisms that metabolize methane, requiring no oxygen and no sunlight. They could dwell in the still depths of methane lakes, beneath tholin-covered ice, or in the darkness of Titan's hidden ocean. Not as creatures we'd easily recognize, but as self-organizing chemical systems. Generating energy, adapting, and evolving by rules no biology textbook has ever imagined. Viewed through this lens, our mission on Titan isn't merely to search for life. It's to expand the very meaning of the word. And if one day Titan answers us with a chemical whisper, a clear signal from its alien world, then it will carry a profound message. That life isn't rare, it's just far more diverse than we ever dared to believe. Titan is more than a distant moon. It is a vital piece in the puzzle that helps the universe break free from our old templates of life and habitability. With everything we've observed and analyzed, Titan has emerged as the most reasonable and compelling candidate in the solar system for hosting a non-traditional biosphere. Nowhere else brings together such a unique combination, an active methane hydrological cycle. A nitrogen-rich atmosphere laced with organic compounds, a subsurface ocean of water and ammonia, and prebiotic chemistry occurring both in the air and deep below the ground. We no longer need to look beyond the solar system to imagine life on other worlds. Titan already offers us a living chemical model. One where water is not required and sunlight is not the dominant energy source. This is no longer just a matter of planetary science. It is a direct challenge to our very definition of what life truly means. if we search for life only through the narrow lens of Earth-based biology, we may overlook entire living systems. Wholly different biological frameworks quietly unfolding in places we've long considered lifeless. It may be a self-sustaining chemical loop in a methane lake. A drifting azotosome structure in Titan's atmosphere, or something beyond even our most advanced simulations. So, the question is no longer, does Titan harbor life? The deeper and far more pressing question is this: are we ready, truly ready, to recognize life in a form completely unlike our own when we encounter it?